right, thanks a lot. Appreciate you. So like he said, this panel is going to focus on the collaboration between Grand Farm, the Northern Plains UAS test site, Thales, and iSight on utilizing UAS systems and AI tools to combat the noxious weed Palmer amaranth. This panel will also cover the opportunities of UAS has in agriculture and technologies like the Vantis network, enabling beyond visual line of sight flights. So with that, my name is Johnathan Gehrke. Like he said, I'm Director of Development for the School of Aerospace up in Grand Forks at the University of North Dakota. I'm really excited to be here. And beyond that, before we jump into it, I just want to say thanks to Emerging Prairie, because you guys do such a good job of taking care of the speakers, the moderators. You just run a really well-run event. And also to the economic developers, the venture capitalists, the associations, the conveners. I travel all around the country raising money for the University of North Dakota, and this conversation has shifted in the last 5 years from nobody knowing what's going on in North Dakota to people asking me, what's going on in North Dakota? So it's an exciting time to be here, and I'm really excited to hear from our panelists, who I will now let introduce themselves. Doug?
Good morning, everybody. My name is Doug McDonald. I'm the General Manager of iSight Drone Services. Conduct aerial data capture using drones in precision agriculture and critical energy infrastructure. And I guess our role in this project was indeed to take images that we then feed to Rex and his team for his work. So, Rex.
Good morning, everybody. And my name is Rex Stuen, and I'm an associate professor, faculty at NDSU, North Dakota State University. And I'm an ag engineer. So my research our group's research involved artificial intelligence, robotics, and remote sensing, specifically in the agriculture applications. So I teach and research at NDSU. Thank you.
Morning, everybody. My name is Jeremy Amundson. I'm a project manager at Northern Plains UAS Test Site. Been leading all kinds of different projects across the state of North Dakota, and then also projects with all the three-letter agencies that you can think of, FAA, DHS, CBP, and got to be lucky and be a part of this project in North Dakota and really, I guess, learn as much as I can about the AI piece of it. And growing up here in Findlay, North Dakota, a little shout out if anybody's here from Findlay, but you know, it's great to be part of this type of work, and Greta and I work pretty close together on this as well.
Hi, I'm Greta Silewski. I work for Thales. It's a global aerospace company based out of France. We have about 80,000 employees. I'm a project consultant, but what that means for me here in North Dakota is I get to work with the Vantis system every day. If you haven't heard of the Vantis system, it is a program underneath the Northern Plains UAS test site. Thales is the system integrator and architect behind the Vantis system. So we get to do all the fun engineering stuff and work on projects like this. So very grateful to Grand Farm and Emerging Prairie for having us.
All right. Thank you very much. So we're going to jump into it. So in North Dakota, there's a number of conversations that are happening that seem to, maybe on the surface, don't seem to be related. We've got conversations about national security and defense work. That's maybe more up in the Grand Forks area with the Grand Forks Air Force Base and the test site. And then this very, the backbone of our economy in North Dakota being agriculture. And this is where this intersection really interests me too, is how are these technologies that are maybe being used right now for defense purposes, can you talk about the connections between those types of research and how we can maybe apply that to this Palmer amaranth problem?
I'll throw the first punch. Yeah, so again, our work, I think, really relies on a lot of that activity to include sensor technology, first and foremost, but I think the whole aspect of autonomous flight, which has been, for front row, has really been kind of a game changer for us in our work, and certainly with the work that we're conducting on this effort to identify Palmer amaranth in the field. So.
I look at this industry as so unique because everything we do, we're building the car as we're driving it. And whether or not you're doing counter UAS stuff with Department of Homeland Security, the first project I was actually ever on here at the test site, I've been here 6 years, was a tailgating event at North Dakota State, South Dakota State, playing NDSU in football. I'm an NDSU guy and I work at UND, go figure. But anyway, at that time it was really all about conducting operations over people, doing emergency management type systems if something were to happen at such a large event like that. And to see the type of stuff that we're doing now and how it's evolved into actually taking aircraft out of the sky for nefarious activities, to doing what is so important in North Dakota, and it's really improving agriculture systems, doing weed eradication through using AI. It just evolves daily, monthly, those type of things. And our job really at the test site is to push things forward by working with the FAA and putting processes and standards and rules and regulations in place so you can conduct these operations more routinely, scale them, and then it kind of leads into Vantis and where things are going beyond that.
Yeah.
Yeah, so we have the test site, and then we have Vantis. Vantis is the commercial arm, so really looking to see how we can, today, right now, you have to bring your own infrastructure if you're a UAS operator. What we are doing in North Dakota is having state-owned infrastructure deployed, so anyone that is on board and out of the system can go and turn right on. I don't know.
It's really just tying in.
Yeah. So, whether it's being able to see who the aircraft are in the sky and being able to identify them through our system, or just being able to separate in the airspace. There's so many things from the Department of Defense all the way down to agriculture, and it's really, they both really connect too, because we talk about our food security. And so this project that we're working on together is really exciting in that way.
Yeah.
To me, Jonathan, I think as a researcher, from a researcher standpoint, I think this is very meaningful and impact a research project that we are doing with the three of this awesome collaborators here. Because to me, everything is precision agriculture, right? We are at the big Aaron show, and you look outside, there's so much technology involved. But the project we're working on is Palmer Amaranth. If you're a farmer, you know what I'm talking about. Palmer is really a big issue out there. And by doing some project like this, we're working with iSight, Thales, and Test Site. And this guys, as a researcher, I want to collaborate with the industry partner because they are the frontliners. To me, understand is they know what farmers' real problem is. As a researcher, I need that kind of feedback to work on our research project. So as an applied research, of course, the fundamental research is also important, but as an applied researcher, we want to work something not only exist on the academic paper. We want to get our research out there, really benefit the farmers. I think this is a really meaningful connection between the industry and the researcher like me at NDSU.
Excellent. That's a great point. And it's really about finding those opportunities where you can. At the end of the day, these are tools, right? They're tools that we're using to drive economic value, to maybe drive safety into areas where a human was involved before. So, those are really interesting points. I was doing a little bit of reading up on this Palmer Amaranth issue yesterday, and it's a lot bigger. I'm not an agriculture's expert by any means, but it's a lot bigger problem than I realized that it was. So, I think one of the interesting questions for North Dakota would be, what are the implications if North Dakota doesn't solve this problem?
I'll go first. I think it will be a huge issue because you look at the other states. I don't want to mention any names, but Palmer is really spread every state across North Dakota, across the United States. And right now, the Palmer, not only Palmer, it's like other herbicide-resistant weed. You can't spray them; it doesn't work. So how you can detect them first? Find them, detect them early, and tell the farmers, okay, you got this, and then so we can tell the farmer early enough to deal with it. And also, we have a lot of robotic companies. Our group is also doing robotic stuff. So we are using UAS system to find it and tell the exact location. And also, we can do something early enough to save the farmers this, right? So the cost. That's going to be huge, because if we can't get a high yield, what are we talking about here, right? So I think this technology like eyesight and test site and Panelists, with all this drone, UAS, and robotic technology, is really can do something and for this problem for the farmers.
Excellent. Anybody else want to jump in on?
Just talking about the noxious weed a little bit. I believe it grows like inches each day and can grow up to 6 to 8 feet. And we find this weed in our row crops. So, and they have thousands of seeds on them. So the earlier we can detect, the earlier we can mitigate, and hopefully not have a problem like some of the other states where it is everywhere.
And maybe this is an oversimplification, but it bears repeating, I think, from the operator's standpoint, from the growers, from the farmers. The efficiency of being able to get out to the fields is a huge issue, because everybody, right, has a workforce challenge. There's not enough people to do all the jobs that are necessary right now. We need more people, or we need more efficient ways to use the people that we have to get the job done. So projects like this, they're going to let the growers get out there quickly, identify the issue, instead of wasting days or hours and hours a week manually going to their fields, finding the Palmer amaranth and removing it. So that's a really important part of this, I think, as well.
Just one thing to add too. I mean, we all know about the workforce shortages, but like you were saying, how do you identify this weed quickly? You have to train the tools that Rex's team is working on, and you do that by flying the fields, gathering thousands of images as part of this project. I mean, we flew in Nebraska and took 35,000 images of Palmer amaranth. And it's really to train the AI tool so we can conduct the flights early on, identify the Palmer amaranth, and then, this is a work in progress too, right? But figuring out ways to remove it. If it is resistant to herbicides, is it utilizing robots? So we're not going out in the fields and hand picking these weeds or whatever it is that farmers are doing when this weed becomes as prevalent as we think it can be. Excuse me.
Can I just add a little bit to the workforce piece? So I think I heard a couple weeks ago that the average age of our U.S. farmer is 58 years old. So as we're looking at just tech jobs, I find it very exciting as a North Dakotan, come from generational farming, that I can be part of our agriculture industry here in North Dakota, but in a completely different high-tech field that, it's harder and harder to get the younger farmers to still want to be interested in their farmstead. So if we can pull different ways, like we're doing here, to make things more efficient, be able to fly not just where you can see your drone over the field, but the longer endurance flights with beyond visual line of sight infrastructure in place. That's where it really makes it a game changer, so we can mitigate these issues early.
Excellent.
To follow up on that, Greta's workforce development. Just this project, guys, we hire like 6 or 7 internships already, right? So to doing this kind of work, and from an educator standpoint, to land up a job, internship is always the first step to get it, because you got an internship opportunity, and then more likely you're going to get a job in the future. So this is great to train the future farmers as well.
And just back to, I think, the workforce and the whole efficiency aspect. So beyond visual line of sight, I think from an operator's perspective, a drone operator's perspective, we're going to be able to gobble up so much more data to be more effective, more timely, which is going to impact the ag producer himself to get in, be proactive on removing those weeds, especially as Rex and his team refine this tool And I think it's going to be an invaluable tool on both saving resources, time, money, in particular for the producers themselves.
Yeah, excellent, very good. I want to keep pressing into this a little bit more about the scope of the problem or the impact that North Dakota can have, because it's important to recognize that this isn't just a North Dakota issue. This is a heartland issue, right? We've got people all the way from Kansas and maybe further away than that coming to learn about these kinds of technologies and these topics. So this really is an issue that if we can solve it here, it has global implications, right? And everybody, I think, here understands how broad of a reach the agriculture industry in North Dakota has. We sell our crops and our products around the world. And maybe to the everyday person, you may not realize how globally connected the state of North Dakota is to the world, but it is. So maybe Rex, you want to jump in on the kind of the global implications and what we can press in on this topic?
I would say just a couple of minutes about this. Yeah, the impact. I think, I want to emphasize that again. There's this kind of a project, I think it's only the beginning, but it's going to be impacted. I think it's not only for our North Dakota, it's globally as well, because Palmer amaranth is just one example of the herbicide-resistant weed. Farmers are dealing with weed daily about the herbicide resistant because we keep spraying them and they learn how to fight against with the herbicide or glyphosate. So that's one thing. The second thing is the chemicals spraying. I heard some rumors, that are globally, especially in Europe, there's a chemical usage. Maybe they want to ban the chemical spraying on the farms. How can you deal with that? So those kind of things push us back to think, okay, what kind of technologies existing or we can develop to identify those weed and then can also get rid of that. And I think this project it's a start and focus on our North Dakota, but if we develop this in a very good manner or a great algorithm, this algorithm can adopt everywhere, right? So for the resistant weed removal. So that's my 2 cents.
Very good. So I want to move on a little bit to the infrastructure side of things. So and for me, this is exciting to be here in Fargo, talking about AI and autonomy and autonomous systems, both on the ground, in the air, and this collaboration between things that we're doing really well in Grand Forks and things that Fargo is doing really well down here. This collaboration of the Red River Valley, I think, is really important for the state. So I'm excited about that. So can you talk maybe more about the importance of the technology known as the Vantis network and dig a little bit more into what that is going to allow for this project?
Yeah, so like I said a little bit ago, currently within UAS, our operators need to bring their own infrastructure if they want to fly beyond visual line of sight. So we are truly enabling with our infrastructure here in North Dakota, being able to see past your drone, be able to fly without seeing it, use an electronic observer in lieu of that human eye, and that's a game changer. When we're looking at the end users, we're talking about a farmer, if they have to be able to see their drone, oops, there's a fly getting me. If they have to be able to see their drone at all times, that takes a person off of something else that they're doing, moving locations. There's just so much more that can be done that the Vantis system helps enable by providing that beyond visual line of sight. It's just the tip of the iceberg.
Doug, you maybe have a personal story that you can add to this.
Well, without a doubt, I think, from an drone operations side, the ability to fly beyond visual line of sight is really going to be a game changer for us from a revenue generation side. I mean, it's straight economies of scale. So currently, if you're Part 107, which is the ability to fly commercially, you're limited to visual line of sight, ideally 1.5 nautical miles. So if you're planted here, you can do 3 miles. With the Vantis network, which currently I think has 3,000 square miles of coverage, right? So our ability to, like one of our aircraft, we did a continuous flight of just under 6 hours. So you imagine the amount of data that we collect if it was, related to farm fields, and the ability to gather that information, stay ahead of, some of the impacts of certainly Palmer, but other things, because we do currently precision agriculture now. Weed detection, plant stands, rock mapping, a lot of things, for us, if we can do it longer without having to put down, it's essentially money in our pocket, which then trickles down to the producer who's buying our data.
Very good. Thank you. So we touched on this a little bit earlier, this issue of workforce. And I want to go back to that for just a minute too. So, I've been involved in other companies where we struggled with recruiting. We were based in the Midwest, and we were in high-tech industry looking for software engineers, electrical engineers, systems integrators, and we were trying to recruit them from the coasts, right? These hubs that are traditionally known for their high-tech industries. I'm really passionate about, we need to be home growing this talent. We need to be providing the educational opportunities for students to learn and grow in these fields here in North Dakota, so that when they're done, they're going back to the family farm and they're taking this new knowledge that they have, and they're staying here in North Dakota. So that's, I think, an important part is, hey, let's get these high-tech careers available here in North Dakota and in the Midwest, so that this is where we grew up, this is where we're from, and it's nice to be able to put down roots and maybe pursue careers that you traditionally wouldn't have been able to in the Midwest. So tell me a little bit about your experiences with either workforce recruitment from other areas or retention, and how projects like this can maybe help solve that problem.
Yeah, I'll start. So we've got the good fortune to be headquartered in Grand Forks, home of the University of North Dakota School of Aerospace. That's kind of been our traditional pipeline, but they come from all over the country to go to school there, and our work also is across the country. So we get our mail in Grand Forks and in Fargo and in Minneapolis, where we have offices, but we work across the United States and internationally. So the ability to give, students from UND, from NDSU, from the State School of Science, a lot of different programs are starting to build up drone-centric curriculum, I think is an opportunity for us as operators and, other providers here in the state to either attract or retain those students that, have the knowledge to really have an, plug and play. For us, training is costly. So if we can get a educated workforce, plug and play, we're ahead of the game, and they like the work that they do. So, that helps.
Very good.
I can give you guys a little bit of information from my educator's observation. So my short answer is the interest out there, definitely there for the future farmers. Why I say that? Because about 5 years ago, we at NDSU we started this precision agriculture program. I was the first faculty hired to teach this class. So I was teaching this class, Introduction to Precision Agriculture. So when we started back in 2019, spring of 2019, I got 10 students sitting in my class. After 3 semesters, I got 60 students sitting in my class. So almost triple the numbers every single semester. So, and interestingly is I also did a survey in my classes. I asked this question: where are you from, and why are you interested in enroll this Introduction to Precision Agriculture? And about 30 to 40% of students who came from a farm background, they want to learn exactly like you talked about, Johnathan. They want to come to the class, learn the technology, and they want to go back to the farm and apply this technology on their farms. So I think the need out there, the future farmers they realize how technology is playing the role in the future. And I honestly think this precision agriculture or digital or AI. I'm a true AI guy too. I think AI can change everything. So it's already changing in the lots of the area. But agriculture is just open a wide door for us. AI can do lots of everything: plant disease, weed detection, all these different things. But it's just the need, the growth is going to be beyond imagination in the future.
Yeah, I guess this issue hits home for me too. I graduated from NDSU and got out as quick as I could and went to Minneapolis because higher paying jobs. Looking back now, I think it would have been great to stay in North Dakota and try to push things forward or find opportunities where I could do this. But part of our mission at the test site is to integrate UAS into the national airspace safely. And then I would say even a bigger piece of that is because we're under the Department of Commerce, it's to keep talent in North Dakota. It's to bring high-tech companies into the state. I mean, 2 companies that are now in Grand Forks are Northrop Grumman and General Atomics out of Grand Sky UAS Business Park. I couldn't tell you how many hundreds of people that are employed out there, but it's a lot. And this type of work with AI and eradicating weeds, hopefully it doesn't just keep people here, but it brings people in, it brings high-tech companies and higher paying jobs. I mean, that's, I would say, a big part of this.
I feel like I kind of touched a little bit on this earlier, but again, like you said, I'm a testament as well. Like, I would have never thought in North Dakota I'd be able to work for a global aerospace company. But I get to do that because of the technology and the systems we're putting in place and the research that is happening here. I guess one little call to action I would say is, if your company is wanting to fly beyond visual line of sight, even within visual line of sight, I'm sorry, this fly is really good. We'd love to connect and talk with you. The more North Dakotans and North Dakota companies and not North Dakota companies that we can have interacting with this system, the better we are off. And the goal is to perfect it here in North Dakota and export it to all 49 other states. So the opportunities really are there. Yeah.
Well, I'll just I'll pile onto that a little bit as a personal testament. I've been back in North Dakota for almost 6 years now. It's the 3rd time in my life I've moved to Grand Forks on purpose. Maybe the first time I was here for my undergrad, I did leave and try to go, and I pursued other opportunities. But at the end of the day, there are exciting things happening in North Dakota, and to be able to come back and to be a part of that ecosystem and that vibrancy that's here, it's really exciting. And not only that, but it's these are real challenges for the entire industry, whether it's agriculture or aerospace. So to know that the work that we're doing here can have such a wide-reaching impact is part of the thing that keeps me here in North Dakota and wanting to keep my family here.
You had said ecosystem, and that's one thing I think is really cool about this project, is having all of the different partners that we have coming together, working on something that could really highly impact our state. And this is just the first project that we're all working on together, but I can see more and more coming down the road and more opportunities.
I think the road between Grand Forks and Fargo is going to be well worn here in the future, so that's excellent.
Johnathan, I heard the football teams don't like each other and between UND and NDSU, but I can assure you the researchers really want to collaborate with each other on various projects. Yeah.
Well, we welcome that for sure. Thank you, Rex. Well, I think we're coming to the end of our time here for this panel. So thank you to everybody who came and who listened. If you have questions, I'm sure all of our contact information is published out there somewhere. I'd be happy to visit with anybody that wants to learn more about autonomous systems, North Dakota, UND. All of those things are near and dear to my heart. And thank you to our panelists for spending the time here to talk about this important project.